Okay, to review the last lesson, let's do a warm-up where we solve these inequalities and graph the solutions. So go ahead and start by pausing the video and working these out, and we'll come back. Okay, let's see how we did. So in that first one, the solution is x less than or equal to 3, and the graph will have a closed dot shaded to the left. In the second one, the solution is x is less than or equal to 2, and we'll have a closed dot again, this time at 2, also shaded to the left. So the lesson for today is going to be on inequalities, solving inequalities, but using multiplication and division this time. Okay, there's our quick objective. And once again, just like the last lesson when we were dealing with solving inequalities using addition and subtraction, we really don't have much that's changed. We are still undoing operations. There will be one thing we have to do differently when we're dealing with multiplication and division, but we'll get to that here in just a second. Okay, so let's look at multiplying by a positive number. So if I have this inequality here, x over 2 or x divided by 2 is less than negative 3, I need to identify the solution and then graph it. Okay, well, just like if I had an equation here, this was an equal sign, I would want to undo the division by multiplying on both sides. And if I do that, then I end up with x being less than negative 6. So when I go to graph, I'm going to have an open circle at negative 6. And since my variable's on the left, I can use the direction of the inequality, which way it's pointing, to help me with the graphing or the shading, and it would be to the left. Now here is the difference between solving an equation and solving an inequality when it deals with multiplication or division. And this you're going to want to make sure you highlight, circle something so you can help yourself retain this. If you multiply or divide both sides of an inequality by a negative number, okay, by a negative number, the resulting inequality is not a true statement. Okay, the only way to make it true is by reversing the inequality. Okay, so we need to reverse the inequality so that we can make our statement true after multiplying or dividing by a negative number. So let's go in and practice this. Okay. Yeah, this is one other point we need to make. This is where a mistake will happen. Before we practice these, just because you see a negative number does not mean you need to switch it. It is only if you are multiplying or dividing by a negative number. Okay, now let's go in and practice a couple. So we want to know what are the solutions of this inequality here, negative 2/3 times w greater than or equal to 2. So when I solve this, like we've done before, okay, I would really want to divide this by negative 2/3. But I know that dividing by a fraction is actually the same as multiplying by its reciprocal. So I'm going to multiply it by negative 3/2 on the left and negative 3/2 on the right. If you need to, make this whole number a fraction. Okay, once I simplify that work, I find out that w is less than or equal to negative 3. But notice what I had to do, right? Here my inequality is actually pointing to the right. Now when I multiply by the negative 3/2, I have to flip my inequality symbol around to make it correct, to make a true statement. So let's graph it at this point, which you guys are probably getting really good at this. This time it's going to be a closed dot, shaded again to the left because I'm making sure that my variable is on the left. Okay, here's another one. We want to solve this inequality. Well, right now, we're dividing by -3. So to undo dividing by -3, we're going to multiply by -3 instead on both sides. And remember cross-canceling here. And then we'll simplify, right? On this right-hand side, I'll have only the x. On the left, notice I have a negative times a negative, which will give me a positive value, okay? Now, when I finish it the first time, look what I've got. I have the x on the right-hand side, and I'm not a big fan of that, so I'm going to flip it around, right? Let me go back and show this. Okay, I would have ended up with this right here, less than or equal to x, okay? I've already flipped my inequality in my actual solution here. Okay, but I'm still not done because I like to have the variable on the left-hand side. So once I get to this point, I'm going to finalize it with one last step where I flip the whole thing around now. My variable comes over to the left, my number goes to the right, and I reorient my inequality symbol. And the graph of that will look like this here, closed dot at 24 and still shaded to the left. Let's try one where we're dividing by a positive number with some context. So the cheerleading squad is doing a car wash, and they earn $5.50 per car. How many cars does the squad need to wash to earn at least $77? Well, let's see if we can get this set up. So C is going to be the number of cars that they wash. And so if I do this right, I realize that for each car, which I don't know how many we're washing, but each one I get $5.50, okay? Which makes that a multiplication problem. So if I want to know the number of cars that they need to wash to get to $77, this is what I'll end up with, right? I need at least 77. Now it could be more, and that's okay. So to solve this equation, we just need to divide by $5.50 on both sides to get to the 14 cars. Okay, so at least 14 cars. If they wash more, obviously they'll make more than $77. Okay, so let's see what else we got here. Let's try another one. Okay, here we go. So this one, I'm going to let you work on this one on your own. So go ahead and pause the video and we'll be back. Okay, let's see what you came up with. See if it matches what we have here. So you should get that your variable is greater than -6. And if we graph it, you'll have an open dot at 6 and it will be shaded to the right. Okay, let's do dividing by a negative number now. Okay, so we want to know what are the solutions if I were to find what they are if I had -5a greater than or equal to 20. Graph the solutions. Boy, I can't talk for some reason. Okay, so we want to find the solutions for this inequality. Thanks for bearing with me. So to do that, all I'm going to do is divide both sides by the -5. -5. Okay. So since I'm dividing by a negative number, the inequality needs to change directions. So instead of pointing to the right, we have it pointing to the left. Now I just go through graphing. Close dot at -4, shade to the left. I'll let you work this one on your own. Go ahead and pause the video. Okay, let's see what x is equal to, sorry, not equal to. Let's see what x is. It can be less than -7. And when we graph it, we have an open circle because it's less than, not less than or equal to. And we shade it to the left. All right, here's some tricky ones. Let's look at this first one. So we have 10 is greater than or equal to -x. Well, I really want it to be x, not -x. And the way I do that is this. I'll show you the answer there. But the way I go through this problem is, in order to get rid of the negative sign on the x, I have a choice. I can either divide by a negative or a -1, or I can multiply it. Okay, now I like to divide it. So I'm going to divide it by a negative sign, or you can use -1. If I do it to the right, I got to do it to the left. Okay, and that's how I end up with this answer. Now remember, I'm dividing by a negative. Okay, so my inequality has switched around. Okay, but I also don't like my variable being on the right. I'll need to switch that to the left to help me with graphing. So there's what my graph's going to look like. We have a solid dot at -10, and we're graphing to the right. I like having that variable on the left-hand side because I don't have to think through as much how I'm going to graph the answer. Okay, let's look at the next one. So I have 16 is greater than -2h. So to undo that -2 times h, we'll divide it by -2 on both sides. And when we do that, we end up with -8 is less than h. Okay, notice we switch the inequality. But now, since my variable, again, is on the right, I need to switch the whole answer, okay? And when we graph it, we have an open dot this time and shaded to the right. Okay, so hopefully you find these to be fairly simple and straightforward, dealing with these simple one-step inequalities. We'll get a little chance to practice them. If you have questions, make sure you bring them to class and let's go over them.